Alright, so the very last thing we're going to talk about today are arc length and area of a sector. So we've already talked about arc length before. It is, the little space around the circle made by our angle. So I'll draw a picture to remind us. If we have a circle and we know the radius of our circle, and maybe there's some kind of angle happening. This line going around the circle in the space that the angle makes is our arc length. And we usually call arc length by the letter S. Arc length S, radius R. All right, so here's our definition that we're about to find. If theta is the radian measure of a central angle, so that's this angle in our circle, of a circle of radius R, and if A is the area of the circular sector determined by theta, then this is how we find the area of that sector, 1/2 r squared theta. All right, so what is a sector? Well, a sector is basically this pie piece that we make by our angle. So this green stuff is the sector. And so this area equation gives us the area of that sector. All right, one thing to note is this definition only works for radians. So if you have an angle given in degrees, you're going to have to convert it to radians first before we could use any of this business. Okay, so number 7 says, determine the area of the circular sector with central angle 120 degrees when the radius of the circle is 5. First thing I notice, I need to find the area of a sector, but my area definition only works for radians. All right, so that means I need to convert my angle to radians. So if we have 120 degrees, I'll let you guys think about it. How do we convert this to radians? Remember, we want to cancel out the degrees. So we have to multiply by pi over 180. All right, 60 goes into both of those numbers. So we get 2 pi over 3 is our angle. All right, so what do we have here? So we have a circular sector. The radius is 5. And this angle in here is 2 pi over 3. And so now we have everything we need to find the area of that sector. It's 1/2 times the radius squared times our angle in radians. All right, so I see I'm dividing by 2, multiplying by 2. Those will cancel, so we'll have 25 over 3 pi is our area. Okay. Number 8, part A says, determine the length of the arc subtended by the angle beta below. So here's our angle. Note that it's given in degrees. That's a red flag. All right, and we want to find the length of this angle. All right, so do we have any equations that help us or that talk about arc length at all? We do. We have the way that we measure angles in radians. All right, remember, an angle in radians is arc length S divided by R. All right, and this is our S, 3 is our R. Again, this angle is the angle in radians. So maybe we can use that to help us figure out what our arc length is. So first things first, let's put our angle in radians. All right, so our angle, we have 155 degrees. we can convert this to radians. All right, so this reduces to 31 over 36 pi radians as our angle. That was the first step. Now we can use this equation to solve for arc length. All right, so theta, 31 pi over 36 equals S divided by R, which is 3. All right, and so to solve for S, we just need to multiply both sides by 3. Okay, and then 3 goes into 36 12 times. So we find that S is 31 over 12 pi. So that is the length of this arc. All right, next, part B says, determine the area of the circular sector with central angle beta. All right, so remember we have our area equation. Area is 1/2 times the radius, so this is something you will need to know. 1/2 times the radius squared times our angle. Angle must be in radians. Okay, so that's 1/2 times 9 times 31 over 36 times pi. 9 goes into 36 4 times. So we have 31 over 8 pi. All right, so at the end of this section, make sure that you can find degree and radian measure and convert between the two. Make sure that you can determine coterminal angles and then find arc length and area of a sector of a circle. All right, make sure you ask me questions about things you are unsure about in class.